All right, so hello and welcome to this the Big Why series. The Big Why basically, math is a field where we often come across this question: why is happening this? Why is this? Why do we have to do this? And why do we have to study maths? So, particularly, why is the big question in mathematics? So today's big why that I want to discuss with you guys is why any number raised to the power 0 is 1. Why any number raised to the power 0 is equal to 1. So this is the question that often people do not understand. Why is it? They just know it's equal to 1, but the logical or the practical examples that where we can practically use, they do not know about this stuff. So today we are just going to talk about why does a to the power 0 is equal to 1, and that's our main goal, is to understand what is the relationship between a 0 and 1. What do they tell us? What's happening over here is nothing but some relationships are taking place, and based on that relationships we are getting some values in the form of output. So to understand this basically, we'll just go backwards a bit, and we'll understand some technicalities. I would rather say about maths and how things were developed in maths. So mathematics was initially developed to describe relationship between everyday quantities, like whatever quantities we have with us. All right, and that too generally whole numbers we are speaking about. There might be some fractions also, but we are specifically focusing on whole numbers today. So the best way to think about powers like a to the power b, or a raised to the b power c is equal to c. This answer basically represents the number of ways you can arrange sets of. The important thing is that the sets of over here. So what c represents, that you can arrange the number of ways you can sorry you have the number of ways with you to arrange sets of b numbers from 1 to a, the collection. Okay. All right. So what do we have is this relation. This describes the relation that c represents the number of ways you can arrange sets of b. Sets of b. Well, we all know what sets are. Sets of b, numbers from 1 to a. So starting from 1 up to this a, whatever the a may be, we are going to arrange the sets of b numbers. All right, so let's consider an example, and we understand this kind of definition through the example only. All right, so this is the example with me. It says that 2 to the power 3 is equal to 8, that we all know exactly. So 8 represents the number of ways to write. 8 represents the number of ways to write set of three numbers. Well, set in which there will be three numbers, where each number can either be 1 or 2. What does this say? That you have 8 different ways to write a set of three numbers. Well, set is nothing but the collection of numbers. All right, collection of quantities or objects. So you have three objects with you, or three types, or three objects with you, or the set consists of three numbers in it, where each number can either be 1 or 2. Now what it can be, what does it look like? It look like in this way. So either you have triple ones or triple twos, or you have the combination of 1 and 2 with you guys. So there are total 8 combinations with you, in which the sets are of three numbers consisting of either 1 and 2, or only 1 or only 2, or both. So let me just tell you by an example. What exactly does it means. All right, so let's consider you have chocolate 1 and chocolate 2 with you. You have two chocolates with you, and in a given day you can eat only three chocolates. Supposing that you can eat combination of these two, or you can eat only chocolate 1 or only chocolate 2, but you can eat three chocolate, and you have this freedom that you can eat three chocolates. All right, so what are the possible ways, and how are you going to eat those chocolates? Are nothing but this. So this represents that in a given day, either you can eat only chocolate 1, you can eat the combination of chocolate 1 and 2. All right, or you can eat only chocolate too. So basically what's happening over here is this, that when you consider this exponent form 2 to the power 3 and you get this answer 8, it represents some or the other way of representing some things which are being performed by you, in our case you were eating chocolates, and based upon your choices you were eating either the combination of them or only one of them. So this is nothing but this is what you can say raised to the power describes to us. It says that this is the way you are going to get some things. This is the way you're going to get some things. So now let's just move on to this, to the power 0 stuff. All right, so if now that I know that exactly, now that I know exactly what a to the power b represents, it represents that, it represents that c is the answer of a to the power b, then c represents the number of ways you can arrange sets of b numbers. You can arrange sets of b numbers starting from 1 to a. So for the sake of understanding, let's consider 3 to the power 0. Then what does 3 to the power 0 represent? Well, I can say from this definition for sure that it is the number of ways you can arrange a number. From 1 to a. Our a is 3 in this case, so 1, 2 and 3 into list, and list were something over here, yeah, exactly, into the list containing none of them. This is what 3 to the power 0 represents. So let me just put it in this way also. Like you have or let me ask you some question. Okay, how many ways are there to place a 1 rupee, a 1 rupee coin, a 2 rupee coin and a 5 rupee coin on a table such that no coins are on the table. Well, I am asking you guys to place the coin 1, 2 and 5 on the table, but in such a way that there should not be the coins 1, 2 and 5 should not be on table. And how is that possible? Well, there is only one way to just perform that task, and that is by not at all placing coin 1, 2 and 5 on the table. Well, apart from that, you cannot do anything. It's just what I have asked you. I have asked a simple thing, that you do not have to place either 1 rupee coin, 2 rupee coin or 5 rupee coin on the table. And how are you going to perform that? Well, you are going to perform it by only one way, and that way is by not at all placing any of them on the table. So you had 3 coin with you and didn't have to, or you don't have to place any of them on the table, and there is only just one possibility for such kind of operations. And that is why, well, if it's true for these 3, then it's true for any number you consider except not equal to 0. All right, it should not be 0, because 0 is something which do not exist, and you cannot arrange or you cannot perform things which do not exist. All right, so we are considering only the numbers which exist with us. So that is why the definition also said from 1 to a, and that is why, this is the reason why a to the power 0 is equal to 1. It's just because it says that how many ways you are going to have to perform this task. Well, in this case you had only one way, by not placing any of the coins on the table, and that is why a to the power 0 is equal to 1.